Professor, this is going to be my project report. So the problem that was studied is the variability in weight of randomly selected clementine oranges, and the continuous variable studied is the weight of a single clementine orange. The data was gathered using a food weighing scale with a readability of zero point 0.1 grams to calculate the data of 41 sample oranges. For the normality assumptions, a large sample interval of 41 samples is taken so that the standardized variable has approximately a standard normal distribution. These are the 41 sample data that were taken using the weighing scale. And then for the calculations, the mean and the standard deviations were manually calculated using Excel. And for a closer look, the 41 sample data were inputted into Excel and the average and the standard deviations were calculated. And then the mean and the standard deviations were also calculated using the descriptive statistic analysis tool on Excel. And using this function, the margin of error for the confidence interval was recorded to be 1.248. Using this data, the confidence interval was hand calculated and it came out to be 77.142 to 79.638. This means that 95% of the time this interval will catch or contain the real value of the population. In conclusion, according to the data, the average weight of the sample is 78.39. Confidence interval is 77.142 to 79.638. The minimum weight recorded is 71 grams and the maximum weight is 85 grams. For the recommendations, the conclusion that the interval would be able to catch the real value 95% of the time seemed unreal. One of the reasons might be that the real population of the clementine orange around the world is difficult to determine. The sample oranges were actually collected from the same location, therefore, the sample information obtained cannot be used to represent the whole population around the world. To improve the randomness of the selection, we can increase the range from which the sample oranges were taken. This way, the sample could be a better representation of the real population. So that's